Here was a good, oh, did I write it down? Oh, I didn't write, I left it in my office. All right. So somebody sent me a question, and then anyway, come grab it. If you email me a question, I left it in my office. And I don't want to run back and use up time. So grab me at the break. I'd be glad to help you with that one. I was going to do it on the board, but I forgot to write it down. So, all right, let's just move ahead then. Yeah. All right, here we go. 1519. So our plan, we'll take a break halfway through, right? At whatever halfway through is. At 10:30 plus an hour and a half. Noon? Yeah, it's right at noon, huh? All right, so here we go. So multiply by 1, 15/19, denominator 19a. It's kind of a weird question. What are they talking about? They want you to take 15/19 and they want you to make the denominator become 19a. It's just a common denominator exercise, but they're saying it kind of strangely. So what do they want you to do? They want you to basically say what needs to be done, top and bottom of that first fraction, to make the bottom become 19a. Yeah, it's just multiplying by a, huh? Does that make sense? Just multiply by an a, top and bottom like that? And so this will be 15a over 19a. And that's it. We're done. It just seems kind of like, really? But yeah, that's all they want. They just want to practice with common denominator. They're just saying, hey, how does 19 become 19a? Well, you multiply top and bottom by a. Right, okay, do that. That's all they're doing. They're just common. Later, not very much later in the summer, like 2 weeks from now, we'll be doing crazy big x's and y's everywhere, and we'll be making the denominators the same. And so they're just getting you warmed up for that. All right, I'll move quick, but you stop me if you have questions. Plus, it'll be on the YouTube later to watch as slow as you want. So here we go. 8 over a is what? Over a squared. Give that one a try. So they're giving you the new denominator. They want you to figure out the new numerator up there. All right, so what do we multiply top and bottom to make the old denominator become a squared? Yeah, another a, huh? Because a times a would be a squared. And whatever you do to the bottom, you have no choice. You got to do the same thing top and bottom to keep the balance, huh? So what's the new top? 8a. Like that. We good? That's all they want.
How would you put the square in the answer box? Like.
Oh yeah, they have a little power thing. Okay, so they've got negative 500 RS over 240 RS. So they want me to reduce. Can you reduce that thing? Like reducing a fraction?
Yeah.
Let's go ahead and do that. So the R's and the S's just cancel, huh? And then what do you do with the 540 over the 240? Yeah. First off, yeah, I like that idea too. Just divide by 10. I think that's all you can do, huh? Be 5 over, just cutting off the 0, in other words, huh? Negative 5/24. We're done. Just reduce that fraction. Is that okay? Questions on that one? Okay. You're going to do, this is a little bit of a weird section, but it's not hard. When you commute, you go back and forth, right? To work, back and forth. So that's what the commutative law is. It's when you move the things back and forth. You trade positions. So when they give you this and then they say use the commutative law, they mean turn the thing around. That's all they mean. Done. That's all they want you to do. They just want you to grab it, turn it around. You know the order of adding doesn't matter, huh? And you can turn that's all they're wanting. They just want to say, hey, you show us the commutative law. That just means switch the order. It's a fancy word for switch order. I'm not going to test you on those fancy words. I don't really care. You get a 3x5 card anyway, right? Did I mention that yesterday?
Yeah.
On the test, you get a 3x5 card with anything you want front and back. First test is Thursday, day after tomorrow, huh? And the test, by the way, if you wonder how far it goes through 2.4. You can tell right on the back side to the little bold writing next to it. 1.1 through 2.4. It's our exam on Thursday. Even tomorrow, we're scheduled to take a practice exam. So we are moving. I took chemistry one time in the summer. And that was my life for that 6 weeks. It was crazy. It just chem. We had regular class lecture, and then we had lab, and then my buddy and I'd go back to the library and just study till nighttime and come back the next morning and start again. 6 weeks, it was my life. All right, so commutative law, flip them, right? Just flip them. Nothing more fancy than that. Commutative law. All they want you to do is just give it a flip. Done. That's a T. My T's don't look so good. Good? Just turn it around. Nothing more fancy than that. Commutative law. All right, I'm going to rapidly move along if that's okay, because they get much harder in section 2.3. Little tiny law. That associative law is where you just jump the parentheses. Associative law, jump the parentheses to the other two. Because it's basically saying who you associate together. So in other words, the associative law would end up just put the parentheses on the first two instead of the back two. Done. That's all. It might seem, does all this seem silly? It would to me. If I was you, I'd be like, well, this is just kind of dumb. They're just, you guys know, like if you're just adding three, let's just do three numbers, like 1, 2, 3. If you're just adding them up, that's 6, right? It doesn't really matter if you associate the back two together, 1 plus 5, or associate the first two together, that'd be 3 plus 3. Either way, it's 6. That's all they're pointing out, is when you're just adding three things, it doesn't matter if the parentheses are on the first two, associate the first two, or associate the back two. That's called the associative law. Now, it's not true in every situation, right? If I had 1 plus 2 times 3, 1 plus 2 times 3, putting the parentheses at the back or in the front would be different, wouldn't it? Would it? What would this be? This would be 1 plus 6, 7. This would be, what, 3 times 3, 9. Be different, wouldn't it? Associative law wouldn't work, wouldn't be true for that setup where you got some multiplication, some adding. Associative law wouldn't be true. But if it's all just adding, associative law is true. Anyway, you don't have to discern all that. All they want you to do is jump the parentheses. That's all you need to do for now. I'm just letting you know what it's even all about. Just jump the parentheses. That's. If I'm going too quick, let me know. Feel free to speak up. I know I'm a fast talker. All right, so this one they're saying use the commutative and the associative laws to find 3 equivalent. In other words, long story short, find the one that's not used the associative and commutative laws. Let me say that one more time. One of these 4 has not used both laws. The other 3 have used both laws. What laws? Commutative, what does commutative do? Switches the order. And associative, what does associative do? Moves the parentheses to associate a different 2 together than the original. 3 of those 4 have used both laws. One of them has only used one of the laws. Which one is it? Can you tell which one, A, B, C, or D, has only used one of those 2 laws and really not used both laws? Is it A? Yeah, I think you're right. Isn't it A? Yeah. What has A not done? Good job. What has A not done? Switch the order. There's no order switching. Totally. Good observation. A is an exact, even though they've moved the parentheses, they've done the associative thing, they have not changed any order. See how A is in exactly the same order as the original? S, then T, then 46. S, then T, then 46. So they have no commutative law. They never changed the order. That's what the commutative law says. You can switch the order, huh? They never changed the order. So that would be the one. The other ones, B, C, and D, they all changed the order somehow. Somebody's order's moved, right? They're out of order somehow on B, C, and D. So they've done the commutative thing. And they've also done the associative thing because they've been jumping the parentheses around. Haven't they? Are you sure? Yeah. S and T are associated originally. S, now it's 46 and T. Here it's S and 46. Here it's also S and 46. So that's different associations, and there's different orders. So the other 3 have used both laws. So the only one that has not used both laws is A. Good? All right. Here we go, 16. p plus 3. So what do you do when you got like a number or letter or anything right up against a parenthesis wall like that? Yeah, it's going to multiply, and it's going to multiply everybody inside. What do we call that? Distribution, yeah. I'm not actually into the names, but yeah, distribution. Just like I'll distribute the practice test tomorrow, I'll pass one out to everybody, right? We're distributing the 16. He's passing himself out to the p and the 3. He'll multiply the p and he'll multiply the 3. 16 times p, 16p. 16 times 3, 48, and we're done. Is that good? You know that already, right? The distribution law, anything up against the wall of a parenthesis. So the parentheses drop. By the way, notice there's no more parentheses on that one, right? They drop, the parentheses drop off, and whatever's in the front multiplies both the things on the inside. That's pretty much the way this book works. So, all right, so same thing, parentheses and everything, but now with a fraction. So try the same thing. Take that 3/4 and go boom and boom. Multiply both those on the inside. Okay, so the trick is, how do we do the 3/4? You know, the 3/4 just goes next to the b, goes next to 12. But how do you do it with the 12? You guys comfortable with that? How do we work out this 3/4 times 12 thing? What do we do when a fraction is interacting with a whole number? Yeah, put that fraction over 1 like that. Make it look like a... Because 12 over 1, that's still just 12, isn't it? Dividing by 1 doesn't change it at all. Still just 12. But now we can deal with it better. How do you deal with that? What do you do? Cross cancel. 4 goes into 12? 3 times. Now notice, cross those out. I've noticed students have a tendency to not want to like show the crossing out or whatever. Make it big and bold, crossing out, just so you know those are gone. You don't get confused that they're still there or think you should multiply them or something like that, you know. Just get rid of them. Just cross them real boldly out. And then what's left over? Just 3 times 3, huh? I mean, over 1, but who cares about over 1? That doesn't... Divided by 1 does nothing. So that'll just be 9. 3/4 b minus 9, and we're done. Is all well? Good? Okay with those fractions? I'm glad to help with fractions. I know those are problematic. They'll just keep throwing them at us. Okay. So 7/12. We get an x minus 2y minus 3z. All right, so take that 7/12, go boom, boom, boom. Hit all 3 of them. Boom, boom, boom. Is that good? So that 7/12 goes to all 3. And then see if you can work out the middle one and the right one. All right, so what do I do right here? You're going to take this 2 and put it over 1, huh? Whole numbers, whenever a whole number is interacting with a fraction, put it over 1. And then 2 goes into 12 6 times. We good there? Just cross cancel. 2 into 12 6 times. So what's left over there? It'd be 7 on the top with a 6 on the bottom and the y. Is that good? In the middle, I mean? The front one is still just 7/12 x. Nothing's happening there. And then the back one is good so far. What do we do with the back one? 7/12 times 3z. Put this over 1. 3 into 12. 4 times. And there we go. We're done with that one. Is that okay? Questions I can answer?
Where's the Z?
What's that? Oh, yeah. Good question. Right there. Thanks. I forgot the Z. Good on that? All's well? All right. So, on this one, when they say I'll list the terms, like a 20p minus 3q plus 20, and then they say list the terms, you're like, what do you mean? What do you want me to do? What they literally want is they just want you to go 20p, comma, negative 3q, comma, 20. I mean, it just seems silly. That's what they want. They just want you to list the 3 terms with commas in between. And that's all they want. Seems too easy, seems kind of weird. They just want you to be clear those are 3 different terms. What do you do if you're ever looking at some Math Excel question, you know, and you don't really know exactly what it is they want you to do? Do you know what I mean? So like this one, this would be a perfect example, right? It's kind of weird. Okay, so we're going to factor 4u minus 64. Do you guys, anybody know, what does factor mean? Factor, what do they want me to do when they say factor?
They want you to take out a GCS.
Yeah, it's like where they want parentheses and they want something in the front, which you write is called the GCF. And then like we'll have two things on the inside, something here with a minus in the middle. You know, yeah, that's what they want when they say factor. Basically, you know what factor means? It means unmultiply or reverse multiply, or however you want to say it. They basically find out what was it before it was multiplied, before it was distributed and became this. What was it beforehand? That's what they're asking. Okay, so how do we figure that out? Well, you look at the 4 and the 64. Take your calculator if you don't know already. 4 does go into 64. So 4 is a common factor. In fact, it's the greatest common factor because 2 goes into both those numbers also, right? But 4 is the greatest number that goes into those numbers. So 4, put 4 on the outside of the parentheses. And then inside the parentheses, you put whatever works. Like 4 times what would go back to 4u? Well, just u, huh? And 4 times what would go back to 64? Use your calculator if you're not sure. Just divide this by 4 and you'll find 16. And we're done. That's all they want. They just want us to find out what was it before it was multiplied. Right? What would multiply, what would distribute to go back to before u minus 64. That's what factoring means. Unmultiply. Questions on that? That good? We'll do a whole chapter on factoring in a while. Not very long, probably next week. So this is just like little. So 72m minus 56n. All right, so parentheses, something in the front. All right, so take your calculator, find out, if you're not sure, find out what, don't say it out loud, give everybody a chance to use your calculator. Find out what goes into 72 and what goes into 56. Now, you know 2 goes in, but yeah, 8 is the biggest thing. 4 goes in also probably, but 8's the biggest thing. It's the greatest thing that goes into the money. You want the biggest amount in common. So 8, yeah, and then figure out, use your calculator if you're rusty on those time zones, figure out what goes on the inside to make it work. So in other words, 8 times what would be 72m, 9m, and 8 times what would be 56, 7n. We're done. Is that good? Factoring, it's unmultiplying. Questions? Okay. So here comes a fraction. So we've got 3/4 x minus 9/4 y plus 1/4, and that is 1 over blank is parenthesis blank x minus blank y plus 1. Okay, so they're giving us those boxes, and they want us to put in those boxes, you know, some numbers that would go back to this. Right? We're reverse multiplying here. We're finding out what would multiply to go back. So what do y'all think?
It's 1/4.
Yeah, we got to put a 4 in this box. Everybody get, because you got to go back to getting that 4 in the bottom everywhere, huh? So you got to put a 4 in the bottom in the front there. Now, good so far. Now, what goes in this box to make it work? Yeah, the 3, and you can just put a normal 3 because you know a 3 alone would really go back to the top, wouldn't it? Why? Because it's 3 over 1. Any whole number is over 1. To be alone is to be up top, isn't it? Right? A whole number really is over 1, really is up top. So all we have to do is put a plain old 3, and when 1/4 multiplies 3x, that 3 will go to the top, won't it? Because it's over 1. And what about in the middle? What do we put in the middle here? 1/4 times what will go back to the middle? We'll just stick the 9, because that will, when the 1/4 goes there, the 9 will stay on the top and the 4 will go on the bottom. It'll be 9/4. Is that good? And the last one, that's all they need from us. We're done. Good? Questions on that one? See how that works? All right, so I've got 9z minus z. Now they're just saying, they're changing gears, no more factoring. Now they're saying, there's just the section just has a bunch of little stuff. It's kind of a review of everything else beforehand, in a little bit. So 9z minus z, now they want me to gather like terms. Remember like terms? Remember how you do like terms? You've got to add or subtract the numbers in the front. Well, what number is in front of that second z?
1.
There's really a 1 there, huh? 9z minus 1z is 8z. And we're done. That's all they want to do. Just subtract, that's like terms. Why do we say there's a 1 understood in front? Well, because 1 times z is just z, isn't it? It makes no difference. I'm not really changing anything. So you could always imagine there's a 1 in front if that's helpful, and it is. It's helpful to have a number to look at. So 9z's, take away 1z is 8z's. Like terms. So 19u squared plus 3v plus 9u squared. All right, can you do that one? So gather the like terms, which is really just the first one and the third one, huh? That one in the middle is different. He just stays separate. So the first one and the back one, front one and the back one, add together 19 and 9, what's that, 28? U squared plus 3v, and we're done. Just add the front one and the back one. Why don't I make that u to the 4th? Why don't I add the powers? When do you do that? Multiplying, yeah. So we'll be getting to that real soon, next week for sure. When we're multiplying letters, then that's when you add the powers and make that u to the 4th, right? But for adding, you just add the numbers in the front. You don't mess with the powers at all. Remember those rules, like terms? Good. Questions? No? Ones. So let's see. So 8s. I wish they wouldn't use s. My s's look like 5s. 2/17 s. Okay. So we're adding up a bunch of like terms there. So how should we do that? What are we going to do with that plain s in the middle? Yeah, it's got an invisible 1, huh? Invisible at 1 times s, that's just s. I haven't changed anything, right? I just put that 1 in. It just helps me, but it hasn't changed anything. It was 1 times s, it's s all along. So now you can add 8 and 1, get 9 and 2/17. 9 and 2/17 s. So far, so good. We can't leave it that way. Why not? Because they say they want fractions. They don't want mixed numbers. The blue line always tells you the format they want it in. If you're not clear what that means, you can click on question help, show me an example, and you would see the look they want. Yeah?
Why wouldn't you make the like 9 over 17 and then just add 9/17 to like 2/17?
Really good question. Let me go back. Yeah. So yeah, 8 and 1 is 9. And I definitely need to add 2/17. You're totally right. But can I take that 9 and just put it over 17? I've changed it, huh? 9 pies is not the same as 9/17 of a pie, right? So in math, we're always doing legal things, meaning things that don't really change it. Make it look different. I always call it plastic surgery to help people get the idea. We're removing the wrinkles, but it's the same person, right? So we're not changing the value, we're changing the look. So that would actually change the value, huh? 9/17 would be totally different. I think what you mean, though, probably what you mean is 9 over 1 and then multiply top and bottom by 17. So it will be 17 on the bottom. That would be totally fine. You're right. That would be totally fine. Harder, though. Let me show both ways. That would be a totally good and right, true thing to do. Because 9 alone is 9 over 1 and multiply top and bottom by 17 to make the bottoms the same. What is 9 times 7? 96, 153 over 17 plus 2/17, which is 155/17, and then you got to throw the S in there. And that's the right answer. That's totally the right answer. Now, I showed you the other way because I think it'll be easier for you. You just go 8 and 1 is 9, and then the 2/17 is just that, 2/17. So you just go, it's 9 and 2/17 S. Can't leave it that way, though, because they said fraction. So how do you convert mixed number to improper? Remember?
You multiply and then add?
Multiply the bottom and add the top. Exactly. You go 9 times 17, add 2. Remember that? So it's 9 times 17, add 2. And you keep the denominator 17, and the S stays in the front as well. Do that, guess what you get? 155. Same answer. So I've just showing you a way I thought was a little bit easier. Just add the 9, 8 and 1 is 9, and then the 2/17, and then just multiply the bottom, add the top. But this way's okay too. Both are right. Questions? All is well on that? You good? Am I flashing these off quick? I'm wanting to push that button, but I can see some of you looking up there at that screen. I feel bad, and yet I'm thinking about 2.3, where they're really ugly, and we all really need to spend. Oh, actually, let me do this. Let me